Well, welcome to another math class. I promised you a balancing act today, and that's exactly what you're going to get, but it's not going to be me balancing on anything. I'm going to be balancing equations. So, continuing with our goal of solving linear equations, today we're going to add balancing equations to our repertoire. There we go, big word. Anyway, so I wanted to talk about expressions versus equations first, okay? You're going to see expressions, and you're going to see us go back and forth between expressions and equations, and I don't want you to stay confused about that. Expressions are just what you see right here, just a simple math sentence. If you like words, it's a sentence, it's a statement, but it doesn't have an equal sign. That's what sets expressions apart from equations. Equations have the equal sign. So here you can see another one. We had 7 plus 3 on the first one, and it equals 10. Now I've got another expression over here, 5 plus x, and over here I have 5 plus x equals 12. Here's our equation. Okay. What you're going to say over here is the sum of 7 and 3, or the sum of 5 and x. All right. Over here you would say the sum of 7 and 3 is 10, or the sum of 5 and x is 12. Here's something you're going to need to know, and you've heard me talk about balancing. All right. Note, the equal sign in an equation equals or makes each side must be balanced, and that's a huge deal in math class. So let's get started on what exactly is that going to mean to us. So we start with that expression that we had, 7 plus 3, or the sum of 7 and 3 right here. And you put it on a balancing scale, and look what happens to it. It gets all crooked on us. But if we make this equal to what you know 7 plus 3 is equal to, we get a nice balanced equation. 7 plus 3 on one side, 10 on the other side. Not bad, right? Well, what if we don't know part of it? What if we don't know one of the numbers? Okay, 5 plus x is our expression, but what if we don't know for sure what it adds up to? Well, we can simplify it or balance it. Here we go. It's equal to 12. Remember, this is the one we just showed a few minutes ago. Notice how balanced it is. 5 plus some other number gives us 12, and it's all balanced. Well, let's start looking at this a little deeper, okay? An equation. An unknown quantity can be represented by a variable, such as x. X is a really popular variable, by the way. Very. It's the most popular variable of all. I don't know why, because it looks like a multiplication sign, but whatever. So, 5 plus x equals 12. All right? Some number. We don't know yet what it is. I know you do know, but shh, don't tell me. Let's see. Did I hit the right button? No, I didn't. Here we go. Okay. So what we want to do is we want to find out what that x is. So in order to figure it out, we're going to isolate the variable on one side. Okay, isolate the variable on one side, but keeping the equation balanced while we're doing it. Ooh, this could be tricky. This is where the balancing act comes in. Cancel out all the extra numbers by doing opposite operations. Remember, we've talked about that before too. What's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. We can do this. You can do this. It's not that hard. But look what happens. If I subtract 5 from the one side, because I'm going to do the opposite. See, what's going on here is 5 is being added to the x. And I'm going to subtract the 5. Because I want the x all by itself over here. I don't want anything else, no other numbers, nothing else, just an x. But if I subtract it, what happens? This side gets lighter, and this side's too heavy. That's not very balanced, is it? I promised you a balancing act. So here's how we fix that. We subtract 5 from the other side. It keeps it balanced. Subtract 5 from the left. We subtract 5 from the right. Ooh, that's falling off. That actually is on there. Okay. So whatever we do to one side, we got to do to the other. That is a silly diagram there. Okay. So when we do that, actually subtract the 5 from both sides, we get x equals 7. I know, you knew that the whole time, right? But this is what we call isolating the variable. It sounded like a big word, didn't it? Or a big idea? But you did it in your head while you were watching me. Pretty cool. Now here's a tip. When you end up doing these on your own, pretty soon you will be, okay? Line up the equal signs, okay? It might even help you to draw a line like this. You're going to see me doing this in class sometimes, okay? Just to keep it all straight and organized. I'm big on organizing things. Okay, so now I want to show you how to do something. This is going to be so cool. See if I can get it to work for us. Okay. All right, let's see if that'll work. I don't want to cover anything up, so I'm going to keep this off to the right just a bit. But watch me. Wait, and you're going to be doing this on your own for your prove it also. Okay, for your try it and prove it, this is what you're going to be doing. So watch carefully. So we're going to do what they call one-step equations, and I want you to see. Now this is for you visuals like Zion, my pal, and I can't even think of who else, but lots of others. So in this little, I don't know what to call this, but this website, they have these cool problems. We can create a problem. We're going to create a model of the problem, and then we're going to practice balancing them, okay, and figure out the answer and get that x isolated, all right? See this x? What number can we add to x? Or to 6, I mean. What number can we add to 6? It'll give us 4. So here's how we do it. First step is to model this equation by dragging a number and x tiles to the scale. So watch this. I'm going to put my x on there, okay, x. Notice, ooh, it got light. And I'm going to add 6 ones, okay? Adding 6 ones, it's getting heavier. There we go, 6 ones, because that's what it says. X plus 6, all right, is right here. Now on this side, I'm going to give the other side, the other part, the equals. So we got 4 over there. Watch this. It's all of a sudden going to balance. Whoa, looky there. Looky there. Okay, now let's check it and see if I did it right. Okay, there are 6 steps by, oh yes, so this is going to take a few minutes to do. Watch carefully. I'm going to check it. Ooh, it liked it. Notice up here, it brought up our equation, okay? Now, our model is correct. Now we're going to solve the problem. So here's what you do. I want to get this x all by itself. So I need to get rid of all of these 1's over here. But I want to keep this balanced at the same time. So I'm going to grab this -1. And if I drag it over here and I put it on that 1, it takes it away. But look what happened. We went all cockeyed. We're not balanced anymore. So I need to hurry up and do that. Whew. That's better. Okay, we got a bunch more to do. You guys get the idea of what's going on here? I'm going to take that one away, and I'm going to take that one away. And I'm going to take that one, whoops, someday. Yeah, there we go. Take that one away, and I'm going to take that one away. And I'm going to take another one away, and I'm going to take another one away. Uh-oh. I still have 2 more to take away. I got nothing to take away here. Oh, we can fix this. Watch. I'm going to take that one away. And guess what? I put in that one. Same thing. Just keep doing it. Come on. You can do this, -1. There we go. And one more time. Yay! It's balanced and we're done. So what do you think x equals? -2 right here. See that? Let's check it and see if I did it right. Yay! Now up here I want to show you. See what? It's showing exactly what we did. I had x plus 6. I added -6, which is actually the same thing as subtracting 6, right? Here I have 4, and I added -6 or subtracted 6, and I get -2. That is the answer. When I'm all done, it's all balanced. I got the x all by itself, and I got just some other numbered blocks over here, okay? Let me show you one more time. I'm going to do another one with you. Okay, we got x plus 7 equals 3. So I'll put my x over there. Let's see. Oh, I got to do 7 of them. Oh, boy. 1, 2, 3, 4, 5, 6, 7. All right, now I got to put 3 on the other side. 1, 2, 3. There we go. Oh, good, it's balanced. That's a good sign. Let's check it. Yay, it likes it. Okay, now we want to get this x all by itself. So once again, we're going to subtract. Oops. Oh, that's bad. Okay, there we go. I hate it when it gets all off kilter, you know? I like things nice and straight. I don't like them all crooked. Here we go. Another one. Oh, and another one. And another one. Are you guessing what the answer is going to be? Again, keeping it balanced. Always doing the same thing. Looky there. It's balanced. All I got left over here is an x. All I have over here is -4. Let's check it. Ta-da! X equals -4. Now, if we wanted to check our work the way you would do as a mathematician, not just, balancing it on this cool little balance thing, you would take that -4 and go back to our original equation and plug it in to test your work. -4 plus 7 is equal to 3. All right? Well, hopefully that will help you a little bit. So what I'm going to have you do in just a few moments is actually, I can get my thing to, there we go. I want you to go to this website and for your Try It today. And I want you to practice balancing equations. Do your own balancing act. You are going to have fun with it. At least I hope so.